a place to stay. Silent and alone, just the wind along the way.
And here we are in the morning of August 9th with Venus and Jupiter. And here we see Venus and Jupiter's rise times only 8 minutes apart here on the 9th. But after a few days, they will both rise at exactly the same time. Venus tends to rise a minute or two later every day, and Jupiter tends to rise 3 minutes earlier than it did the day before. And we are told that Venus is 100 million miles from the Earth, Jupiter is 500 million miles from Earth, and Venus and Jupiter are 500 million miles apart. And here I made a few color adjustments to kind of showcase the self-luminous nature of these lights we call Venus and Jupiter. And we are told that Jupiter is a gaseous planet and Venus is a rocky planet, but this footage here suggests otherwise. So a sunrise and a moonrise are essentially the same thing. We're standing here in Iowa, we're looking to the east, we see the sun emerge from the vanishing point, arc to the south, disappear into the horizon. Same thing with the moon. We're standing in Iowa, we're looking to the east, waiting for the moon to rise. We see the moon emerge from the vanishing point, arc to the south, disappear into the horizon. And so the rising and setting of the sun is very clearly not caused by the entire world doing a somersault every day, but the independent motion of these two unique points of light and energy. So on the winter solstice, the sun's path through the sky lines up with the Tropic of Capricorn. On the equinoxes, the sun's path through the sky lines up with the equator. And on the summer solstice, the sun's path through the sky lines up with the Tropic of Cancer. So when we say the sun goes tropic to tropic throughout the year, that's what we mean. And you can determine this by taking a picture of the sun at the same place every day. And year after year, it makes the same shape, known as the analemma. So whenever you see the sun to the west of the moon, whenever the sun is to your right and the moon is to your left, that's how you can tell we are at the beginning of a new lunar cycle. And here are 3 examples of what that looks like in the natural world. And towards the end of every lunar cycle, the sun will be to the east of the moon will be on your right, and the sun to your left. So at the beginning of every lunar cycle, the sun is just pulling away. And by the time they are 180 degrees apart is when the moon will be full every time. Which is why you never see a full moon in a blue sky. The motion of the sun and the moon is much like a clock. In fact, it is clocks that represent the motion of the sun and the moon. Any clock's accuracy will be dependent on how in sync it is with the sun and the moon. Okay, now we've shown how at the beginning of the lunar cycle you will see that in the sky, and we've shown how at the end of the lunar cycle this is what you'll see. So what begins in the beginning. So for the first few days, the moon will follow the sun on its ecliptic around the world, but the sun will slowly pull away. So as the sun pulls away, after a few days, the moon is going to start cutting through the middle. And as the moon starts cutting through the middle, it's going to start filling up. So the moon starts cutting through the middle, the sun's pulling away, the moon's filling up. Every single time the sun and the moon get 180 degrees across from each other is when the moon will be full. So for this demonstration, we started on the winter solstice on the Tropic of Capricorn, but it's the same thing if we were on the summer solstice. So let's say we're here on the Tropic of Cancer for the summer solstice. We're at the beginning of a new moon cycle. The sun goes around and around. As the moon starts to fill up, she will deviate and head south to fill up on the Tropic of Capricorn. So the sun goes around and around Cancer for summer solstice, and the moon deviates to the south to fill up. And once again, every full moon will be 180 degrees across from the sun. Sun in the north, a full moon in the south. Sun in the south, full moon in the north. So on the equinoxes, let's say we are in the spring and we're starting a new lunar cycle. Here we are on the equator. When we're on the spring equinox, the moon is going to head north first to fill up, and then come back down to meet the sun on the equator for the full moon. So the equinoxes, the full moon will be on the equator with the sun. For the spring equinox, the moon heads north first, and for the fall equinox, the moon heads south first, meets the sun back on the equator to fill up, powers down on Cancer, and then comes back to the equator to meet the sun coming back around, just like they do like clockwork every single month to start a new lunar cycle. So what that means is that the moon does in a month what the sun does in a year. So seasons are the sun coming from the south to the north and back and forth. And we've shown that the analemma kind of charts that path. We're here in December, moving up. Here we are on the equinox, coming around. Here on our solstice, coming back down in July. Here we are on September for our equinox, and it starts over. So the seasons are the sun coming from Capricorn to Cancer, back and forth. It follows this path as we've shown, and the sun also gains altitude as it moves north. So the sun will be moving the fastest throughout the year down here in the Tropic of Capricorn. Now, regardless of how big the sun's circuit is, it takes 24 hours to get around. So from here to here, 24 hours. From here to here, 24 hours. So the sun is moving faster in the winter. And I detail this in my videos, Return of the Sun Part 1 and 2. It's a pretty in-depth explanation of what is going on during the winter and summer solstice. Go watch that if you'd like to understand the sun's motion in numerical values. So the sun is moving faster in the winter around here on its widest circuit and slowest right here, but it also gains altitude throughout the year. So the sun will be highest in the sky for our summer solstice, and then as it moves back to the south, it will lose altitude and gain speed. So the sun goes tropic to tropic once a year. The moon, she does that every month. So whatever month we're in, it's the beginning of our lunar cycle. The sun's going to go around and around. The moon's going to head south. The moon's going to fill up in the south and then return to meet the moon. So with that, the moon has its own analemma shape that it makes throughout the month. So the motion of the sun and the moon is like a repeating pattern, but it's not like a mirror image year after year. There's a bit of a drift. So the moon goes in 19-year cycles known as the Metonic cycle. So every eclipse, every full moon, everything the moon is going to do for one entire cycle happens in 19-year periods. So when we have a new moon align with a winter solstice, that will not happen again for 19 years. But when it does reoccur 19 years later, it will be further to the west than it was 19 years ago. So there is this metonic drift with the metonic cycle where every 19 years it starts over and the moon returns to where it was, but we will be further to the west. And I think we'll wrap it up here for now. There's a few other things I wanted to touch upon in this episode, namely the fluctuation of the moon's rise times and how that correlates to the path that the moon is taking through the sky at any given day. But we will save that for another episode. Thank you for being here. We'll see you next time.